5.03 is the first lesson about equations for circles. So let's look at the equation of a circle. If we began with a circle such as this in the coordinate plane, right now the center point coordinates are unknown, so we just use the letters H and K to represent them. The radius is unknown, and then we have another point on the circle that's unknown. And so the formula that works for this circle and any circle with a center and radius that's given to you is x minus h within parentheses squared plus y minus k within parentheses squared, and that is equal to the radius squared. So from the diagram you can tell that h is just your x coordinate from the center, and then k is just your y coordinate from the center. All right, and so then lastly your r is just your radius. So it's simple, just plugging the values in. Now really quick, what does that formula over there resemble? Does it look a little bit like the formula for the Pythagorean theorem? A squared plus b squared equals c squared, because that's where it comes from. If we were to think about our circle here, the radius can become the hypotenuse of a right triangle. All right, so if you draw the horizontal distance and the vertical distance, you have a right triangle, and the radius is your hypotenuse. So we can see that's all that is happening with our circle equation, is that we just have horizontal distance, vertical distance, and the hypotenuse. That's where the equation from a circle comes from. So now, what if let's give some values in this question. Let's say that the center, instead of being HK, let's say that it is 2, 3. And let's say that the radius is 4. So all you have to do is plug the values into the equation. So open your parenthesis, x minus, always put that minus there. In the problem I decided that h was going to be 2, so plug in a 2 squared, plus, open your parenthesis, y minus, the k over there to the left is a 3 squared, equals the radius squared, 4 squared, which is 16. So there is the equation for that circle. That's it. Now, what if we had to do that in reverse? What if we had to determine the center and radius of a circle given the equation? So again, you simply need to refer back to the standard form, which is x minus h squared plus y minus k squared equals r squared. So we just start pulling values from the problem. Our first one, this x squared, represents this whole piece right there, but it doesn't have a minus a number, does it? So that kind of changes things up a bit. Since there is not minus or plus a number to the x before it is squared, that means that h is simply 0. For the next one, the y plus 3 squared represents y minus k squared. So that means that the plus 3 is our negative k. This is where we have to be careful. The formula makes us put a negative sign in front of the coordinate points for the center. So that means anytime the formula is given to us, even though that looks like a positive 3, k is actually a negative 3. It is the opposite of the way that it appears because of this subtraction sign in here. If it had said y minus 3 squared, that means k would have been positive 3. So it's always going to be the opposite than the way that it appears in the formula. Now, finishing the rest of the problem, the 25 represents r squared. This is another place students trip up. if r squared is 25, that means that the value of r is the square root of 25, which is 5. So in conclusion, the center of this circle, using h and k as the center, is 0, -3, and the radius of the circle is 5.